Hello, this is Andrew Sarkis, and this is my puzzle Happy Pi Day. It's a non-consecutive, anti-knight, German whisper, XV pairs puzzle. Let's get started. I'm going to assume that you already are familiar with constraints. So I'm going to start by selecting all the cells on the whisper, which must be high digits, and pencil mark them 7, 8, 9. As you can see, there's no possible place to put a 6 among these. This can't be a 6, for example, because these two cells see each other by knight's move, so they can't both be 1s. Let's select all the low digits and mark them with 1, 2, 3. This could be a 4, that can be a 4. This can't be a 7, it's next to a 3 on a whisper. This can't be a 3 because it's non-consecutive and also knight's move. This can't be a 3 because one of these must be a 7. These two can't be 7s because a 1-2 pair here would break that, and a 1-2 pair here would break that. So 7s can come out of those. And we get an 8-9 pair with a 1-2 pair. This becomes either a 4-6 or a 3-7 in that order. This can't be a 4-6 because the other 4-6 would go in this domino along with the 5. And that violates non-consecutive, so we get this. And that can't be a 5, so we get a 5 down there. Now we can't put a 6 in the same domino as a 5, so we get a 6 up here. By anti-knight, that can't be a 6, so we get a 6 down here. And we can't put a 5 here for a couple reasons, so we get a 5 up here. Now let's look at this cell. It sees all the low digits except for a 2. And it sees all the high digits except for a 6, because it sees this entire triple by knight's move. And it can't be a 5 because it's next to a 4. Now, we're going to take a 6 out in a moment. To see how to do that, let's highlight these two cells and observe that at most one of these orange cells is a 7, because these three cells all see each other by knight's move, so they can't all be from 1 and 2. Now, if that's not the 7 for the row, then that must be to satisfy the triple. If that's not the 7 for the column, then that must be, because we can't put a 7 here, it sees these two by a knight's move, and we can't put a 7 in a domino with a 6 by non-consecutive. So these 4 cells contain 2 7s, at most 1 in orange, so at least 1 in blue, so that's not a 6, it's a 2. That looks down and does some work down here with giving us some digits and some eliminations. Okay, that's not a 2 anymore, that can't be a 3 by non-consec, that's not a 4 anymore because it's on a whisper next to an 8. And now the 4 in this column can't go up there with a 5, so it goes down here in this domino with the 4-6, or 4-6 pair. And now let's look at this cell and ask what this can be. It sees all the low digits, and it can't be a 7, 8, or 9 because, well, let's go one by one. 8 breaks by non-consecutive, being next to this 7, 8, 9. 7 breaks because it sees these by knight's move and it sees these by row and column, so a 7 here would rule 7 out of all these 4 cells. And 9 here breaks because look what it does to the orange cells. Makes that a 7 by anti-knight and makes that a 7 by non-consec. So 2 7s in orange is not allowed, so that can't be a 9, so it's a 5 or 6. Which means that's not a 5, which means that is a 5. Now let's look at where we can put 4 in this column. Can't put it next to a 5 by non-consecutive. Can't put it in knight's move away from a 4. And we can't put it here because one of these is a 3 and one of these is a 3. So it would violate non-consecutive if we had a 4 in one of these. Now this is basically an X-wing on 3s. So we get a 4 down here. And we can't put a 3 in that domino. And we can't put a 3 in between the cells of the X-wing. We can't put a 3 next to a 2 by non-consecutive, so we get a 3 there. And that takes a 3 out of there. Now where can we put the 5 and 6 in this column? Obviously, you can't put it up here. And we can't put a 5 in the same domino as a 4. And we can't put a 4 with a 6 down here either. We can't put a 6 because this 5 would see either a 4 or a 6. So the 5, 6 in the column goes here. We get a 5, 6 pair, which looks at this cell by knight's move and takes a 5 out of there. And now that disambiguates this. That's a 4, 6. And now we can take a 4, 6 out of there. And now let's go back up here and, well, let's pencil mark these first. This is from 4, 7, 8, 9. That's not 8, 9 because it sees these two by knight's move. That's a 5, 7, or 8. This is a 7 or 9, and that's a 8 or 9. This is a 7, 8, or 9. That can't be another 7, 8, 9 because there'd be an 8 in this domino next to a 7, 9. That'd violate non-consecutive. So that's a 5 or a 6. And one of these is a 6, so that's not a 7. And that's the last 7, 8, 9 for the row. This row needs a 3, 4, 5, 6. By non-consecutive, that can't be a 4, can't be a 3. By non-consecutive, 5, 6 can't go next to a 5, 6, so that's a 3, 4. 5, 6 looks down, makes that a 3, 4. 3, 4 looks over, makes that a 5, 6. Now, what if this is a 5? That makes that a 6, but also makes that a 7, which makes that a 3. And by non-consecutive, it would make that a second 6 in the row because 3 can't go next to 4. So we get 2 6s in the same column, I should say, not row. We get 2 6s in the same column if that's a 5. So that must be a 6. Therefore, that's the 5. That means that's a 3. And that's a 4. That's a 6. And that's a 5. Now 6 goes next to this cell. So that can't be a 7 anymore. And the 7 in the row goes there. And that looks down, makes that a 4. That makes that a 6. That's a 4. That's not a 5 anymore. So that's the 5. That's not a 5 anymore, so that's a 6. And that's a 5. And we can take a 4, 7 out of there. Now we've got this 7, 8 pair. And that sees, this cell sees both of those. So that's not a 7 anymore. That's a 3. Makes that a 6. That a 4. And we can take a 3 out of there. Now let's look at row 4 and ask where we can put a 4. This 4 sees these two cells. This 4 sees that cell. This 4 sees that cell. So the 4 goes there. That becomes a 9. That becomes an 8. Takes an 8 out of there. That 7, 9 pair makes that an 8. And now let's look at 4s in this column. This 4 sees these 3 cells. This 4 sees that cell. That 4 sees that cell. So we get a 4 up here. Okay, and we need a couple more 4s in the grid in column 7. Can't put a 4 there by anti-night, so we get a 4 there. And the last 4 is going to go there. And this 4 looks at that cell and takes a 3 out of that. And so we get our X-wing resolved like that. Now let's look at 6s. And in row 4, this 6 sees these 3 cells. And so the 6 in the row goes there. And now we have a couple more 6s to place. We have basically this X-wing left, but we can't put a 6 next to a 5, so the X-wing resolves like that. Now 5 can't go next to 4, can't go next to 6, so the 5 in this row goes here. In the column, can't put a 5. A knight's moved from this 5, so we get a 5 there. The last 5s in the grid are going to go here, and this 2x2 will resolve later. All right, now the next thing we're going to do is finish this row. 6 going next to this cell makes that a 9, and that's a 7. So now the 1 in the row, let's finish this row first. Okay, so 1 sees these 2 cells, so the 1 in row 4 goes here. This 3 on the whisper is going to resolve the 7, 8 pair like that. And now 7 can't go, nice move from a 7, or it can't go next to an 8 and 6. You know, a couple of different reasons. But that's going to give us that. Now, next thing we're going to do is look at this cell and ask what this can be. It can't be 4, 5, 6, and it's next to an 8, so it can't be 7, 8, or 9. So this is from 1, 2, 3. But since the 3's in these 2 columns mean we can't put a 3 in these cells, the 3 in this row has to go in one of these 3 cells. So we definitely can't put a 2 in the middle cell. And we can't put a 2 flanking this 1, 3. So the 2 can't go next to this 3, so the only place left in row 1 is here. And now we can't put a 1 here anymore, so the 1 has to go in this triple as well. That makes this from 7, 8, or 9, but it sees a 7 and sees an 8, so it's a 9. And that's an 8, and that's a 9. And now 7 can't go next to a 6, so the 7 in the row goes there. 1 looks up, that's a 3, that's a 1. Okay, now to finish this column, we need a 1, 3, and 8. 1 and 3 can't go next to a 2, so that's an 8. 3 can't go next to a 4, so that's a 1, and that's a 3. Now in this row, we need a 9. And it can't go over here because we've got 9s in these columns already. And this 9 looks over here as well as this 9, seeing this cell by knight's move. So the 9 goes there. Now can we put an 8? We can't put it next to the 9, and we can't put it next to the 7, so the 8 in the row goes there. And now the 7 has to go here, and this becomes a 1 or a 2. That 7 is going to resolve this domino here, which resolves the 5s. And now let's look at 3s. We need one more 3. It's got to go there. Let's look at our 8s, and in this row, the 8 has to go here. That means the last 8 goes there. Let's look at 9s. Okay, the 9 in this column has to go here. And the 9 in this row is there. That's the last of the 9s. 7s are pretty close to completing. We need a 7 there and a 7 there. And now we need 1s and 2s. And this 1 sees both these cells by knight's move, so those are both 2s. That 2 looks over, sees this. That's going to unwind all these 1s and 2s. And that's going to be a 2, and that's going to be a 1.